Butanone and propanol. Okay. Abdurrahman, can you please turn the mic on? Yes, Abdurrahman. Are you there? Okay, let me see. Can somebody? Okay, Parvati has done the assignment. Parvati, can you turn the mic on?
Yes.
So in the first question we had, okay, so these are the products of a particular ozonolysis reaction, right?
Yeah.
So this carbon and this carbon, this will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, I think that is correct. And this is another, the same question, right?
Yes, sir.
Type of question. So you just needed to count this carbon and this carbon, double bond CH2. Yeah, that's fine, correct. And then you had, what was this question? I don't remember actually the question. Okay, this is the, okay, fine. This is the reaction. This is the reaction.
Yes, sir. With HBr in the absence of peroxide and in the presence of peroxide.
So I asked you for a product. Okay.
Yeah.
In the absence and the presence of peroxide. Yeah, that's fine. Correct. Very good. Thank you. And who else has done the? Khalil has done the assignment. Preparation and properties of alkene. Okay. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 1 CS3 here. Yeah, that's correct. This is correct. And let us see this one. You have written here. Yeah, that would also work. That would also work. In the presence of HBr, we'll have 2, and the presence of, in the absence of peroxide, we will have, okay, fine, correct. Next is Mamuna, did you not submit the assignment?
No, sir. I'm having my pre-finals, so I didn't get time.
So you're having a pre-finals. So I mean, in your school, this syllabus is done.
Yeah, syllabus is done. We are having term 2 pre-finals. After that, in Feb end, I guess we will have the finals, and in March 12th grade will start.
Okay, on March 12th that will start. Okay. And we have Razan's here. Okay, so CS3. Was this the molecule? Wait a second. Mamuna, do you have the assignment in your laptop? Can you send it through? Good evening, Yusra. Mamuna, do you have that?
Yeah, 1 second.
Yeah, okay, you're sending it. Okay. This one is correct. I feel that this one is correct, but I don't know about this one. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4. Okay, fine. I understand. I think this is butanone and propanone. Butanone, and this is 1, 2, 3. That is propanol. Okay, fine. I think this is also fine. Then what do we have next is the presence of peroxide. So, okay, and in the absence of peroxide. Okay, fine. उल्टा कर दिया था पहले आपने. Who else has done the Minashi? Okay. On this. Okay, let me see what are the changes. Thank you, Mamuna. Fine. Relative ozonolysis of propane, butanone, and propanol. Okay, fine. Let's see. 1, 2, 3. This will be 1, 2, 3, 4 methyl. No? Oh no, this can be 1, 2, 3. Yeah, Fine. 3-methyl and 3A. Correct. Then we have methanol. Na? What do we have? You wrote methanol. Methanol nahi hoga, methanol.
In question, it's like that.
In question, it was methanol. That's not right. In question, it should be methanol. Okay. That's a printing mistake. Okay. And write the products and their impact names obtained when the absence of peroxide and in the presence of peroxide. Here you will have BR. Na, yahan BR aapne likhna bhul gayi, Minashi. Yes or no?
Yes.
Okay. Is there anyone else? No. Raise your hand if you have submitted the assignment and I have not checked that. I have to check up. Parvati, yours हमने नहीं check किया क्या? कर तो दिया आपका? ये तो आप ही का था ना?
Sorry, I heard wrong.
नहीं, I'm saying that I think Abdur Rahman का नहीं किया, but Abdur Rahman is not online, I guess. He's not answering. Let me also check. There's no peroxide, then means 2, and if peroxide is then that means 1 bromo. Okay, fine. This here he has messed up this part here. COOH he has written. I don't know why he did that, and he has also not done this one correctly. Also because I think this is methanol. Fine, not a problem. Let me go back to your class. Today is 18th of Jan. Yusra, you have submitted the assignment? हाँ लेकिन नहीं अपलोड हुआ है. When did you submit the assignment, Yusra? Can you tell me? Yes, Yusra. Okay, already discussed. 14. अच्छा काफी दिन हो गए यानी कि. अच्छा fine. I have told Nishkash sir he will update my OneNote. Okay. Okay, fine. So where did we end the last time? I think we did some preparation of alkynes. Yeah, we did preparation of alkynes, right? Conventional dihalide. Now we also did physical okay, we were doing the chemical properties of alkyne, and we were done with the acidic character. I think so, right? Yes.
Yes.
Now you can write. Okay. Now you can write the addition reaction. Because wherever there is a pi bond, is an electron source, and what it can do, it can add a particular group or element on both of the doubly bonded carbon atoms. Okay. So the next type of reaction that we will look here is addition reactions. Please write. Addition reaction. Okay. So right here, as alkynes contain triple bonds, they can add up two molecules of, so we'll do some reactions with number 1, 2 molecules of H2. Okay. Then we will do halogen. Halogen means X2, and C, I will write HX. So this is hydrogenation. So we'll do reaction of alkynes with hydrogen. This is halogenation. Okay. And then here we have hydrohalogenation. Hydrohalogenation. Okay. Now, write this. Then I will show you a simple type of. We will also do addition of water. Let me write one more point. Addition of. You can also add water. So what will be addition of water? This will be hydrolysis. Hydrolysis. Write this down. Then we will look at the general mechanism, and after that, we will do these reactions: hydrogenation, halogenation, hydrohalogenation, and hydrolysis. Raise your hand if you're done. Now, let me show you guys a general thing that we can see in all of these reactions. Okay. So in almost all of them except one, we will have this hydrogen is having a bond with hydrogen. Here, two X are having bonds like this. Here we have hydrogen and an X bond, and here we have hydrogen and a OH bond. So in all of these, what you can do, at least in two, you can see that there's a negative parts here, that is delta negative. This will be delta positive, right? Here it will be delta positive, and here it will be delta negative. Okay, so you can make this distinction. Now, when you are doing halogenation and hydrogenation, you don't have to look at the product, what the product is going to be, but you need to take care in the C and D, hydrohalogenation and hydrolysis. So let me write a general mechanism. So you will take any alkyne. That means there will be a C triple bond C fragment. Plus, what I'm showing here is if you have anything which has hydrogen and some molecule which is attached here, Z, and here the Z should be more electronegative than the hydrogen. First of all, we will do this in acidic condition. That means I will start with H plus ion. Now, as you know, H plus is what? It has electron deficient species. It does not have electron. It has a positive charge. And the pi electrons here, which are electron rich, they will attack. And what is going to happen will be carbon and the double bond carbon. So this carbon will get a hydrogen. Okay, any one of these carbon will get a hydrogen, and here you will get a positive charge. So this is our intermediate. Okay, this is our intermediate, and followed by what you will have, the Z minus. So what you can see that the Z will take up electrons from here, and what will happen? The Z will attack the carbon from here, and you are going to make hydrogen here. There will be a double bond, and there will be Z here, like this. Okay, so this is a simple mechanism. One of the carbon. Now, which carbon is going to get? What will be the intermediate? So again, you have to keep in mind for unsymmetrical alkynes. For unsymmetrical alkynes, addition takes place according to Markovnikov rule. According to Markovnikov rule. So write this down. Let me know if you're done. Okay, so write a reaction. Number one, hydrogenation. That means addition of H2. Addition of H2. So the reaction will be something like you will have C triple bond C. It will start with a simple reaction H and H plus H2. In the presence of, let us say, you can have PD, PT, PD, or nickel, any one of these. And what you are going to get is one of the hydrogen. You can take it like this, and hydrogen here. So one of the hydrogen will attach on this carbon, the other will attach on this carbon. Yes, Mamuna, you want to say something?
No, sir.
Achha. Okay. So both the hydrogen will add up on one of the pi bonds, and you will get CH2 double bond CH2. But again, please remember that this reaction will not stop here. Why? Because we can have excess of hydrogen. The reaction can proceed again. If you have more H2, then this H2 will it will add up to this alkene now. Okay, this alkene now. And what you are going to get is a CH3 bonded to CH3. CH3 bonded to CH3. Now, it doesn't matter whether you have a symmetrical alkene or unsymmetrical alkene in this case, because the reagent here is symmetrical. Okay, if both of them are unsymmetrical, then only we have some problem. Otherwise, it is fine. So here we have symmetrical alkene, and here we have what? If one of these things are symmetrical, and it doesn't matter. So if you have, let us say, propene plus, no, let me write it propine, not propene. So you'll be having CH3 single bond C, triple bond CH plus H2. So it doesn't matter where the hydrogen is getting bonded, because both of these carbons, only we have hydrogen, we don't have anything else. Okay, that is why you can add it to any of these carbons. CH3, this will be having CH double bond CH2. Then again, if you add H2, you will be getting CH3 single bond CH2 single bond CH3. Okay, similar things can happen if you have large molecules also. For example, if you have CH3 single bond C, triple bond C, single bond CH3. So this is going to give you CH3 in the presence of H2, right? CH3, CH double bond CH, single bond CH3. Then again, one more molecule of H2. And we have written here, it can add up how many molecules? It can add up 2 molecules of hydrogens, halogens, hydrohalides, and then water. This is going to give you CH3, single bond CH2, single bond CH2, single bond CH3. Okay. So simply, if you want to go from alkyne to alkane, what you can use? You can use hydrogen in the presence of a particular metal, in the presence of a particular metal. Okay. So for example, if I say, what reagent would you use to convert propine to propane? Okay, so simple, this is what? Addition of hydrogen. So you'll write, but please remember the same number of carbon atoms should be there. Answer will be H2 in the presence of PD, PT, nickel. PD or PT or nickel. Write this down. Let me know if you're done. If you remember, we have done these things in the preparation of alkane, right? Hydrogenation of alkyne and alkene. We have done this. Okay, write this down. Let me know if you're done. Okay. Good. Seems like you guys are done. Just let me know if you're not done. Okay. I'll scroll up. Right, next, addition of halogens. Addition of halogens. Now again, in this case also, you have simple reaction, because halogens, that means you will be having X2. Now we have the reagent which is symmetrical. It doesn't matter whether the substrate is symmetrical or unsymmetrical. We don't have to worry about the product. So even if you have, let us say, CH3, C triple bond, CH, and if I add some molecule here, right? Br2, then it is going to give me CH3, and this carbon will get a Br double bond, and this carbon will get a Br. Okay, then again we can react this one more time with Br2 again, Now, once more, what you will be getting, CS3 and Br will be added on this particular pi bond. So this carbon atom will also get a Br. Here we already had a Br, single bond C, H, and then there will be Br, and then there will be Br. Okay, simple reaction, addition of halogens. Just write a note. Br2 is orange in color. Br2 is orange color liquid. Orange color liquid. Okay. On reaction with unsaturated hydrocarbons, it turns colorless. And hence used in test for unsaturation. Write this down, let me know if you're done. Done, guys?
No, sir.
No? Okay, fine. Raise your hand if you're done. Okay. This one is done. Okay. Right, next. Addition of hydrogen halides. Okay, what I am using? Yeah. Hydrogen halides. Okay. Now these will be either HCl, HBr, or HI. Now in this reaction, you have to just keep a note that it follows Markovnikov rule. So halogen is attached to more substituted carbon, Now, let us say, for example, if I have propine, and if I add HBr, so addition can take place in 1 and 2, right? So one of the carbon atoms of these two, it will be getting attached with hydrogen, and the other carbon will be getting attached with bromine. So can somebody please tell me, bromine will be attached on which carbon, 1 or 2? Bromine will be attached on which carbon, 1 or 2?
1.
1 carbon, right? Because it is more substituted. So we have CS3, single bond C. Here there's a bromine attached. Now there will be a double bond, and this will be CH2 now. Now again, we can add HBr to it. And again, it is going to follow the Markovnikov rule, that is Markovnikov addition. Now in this case, we will be having CS3, single bond carbon. There will be a Br here, and this is the old Br that we had, and here there will be single bond and CH3. Okay. So write this down. Let me know if you're done. Similarly, you can write the same type of thing for addition of water, right? Addition of water. So this also follows what? Markovnikov's rule. Follows Markovnikov's rule, and that means in this case, the OH group will be attached to more substituted carbon. So in this example also, I'm going to take the propyne CH3 single bond C. Sorry. Okay. Now in this case, you have to add here. You have to add here Hg2 plus in the presence of H plus. Okay, in the presence of H plus, and also some heat. Then the main reason is that this alkyne that is not very much soluble with water, because alkyne is what? It is a non-polar substance, right? And it is like weakly polar substance, not non-polar completely, but weakly polar substance, water, whereas it has hydrogen bonding. So hydrogen bonding and weakly polar, so they are not like, and we have the rule that like dissolves like, so you should have same type of intermolecular forces of attraction if you want to dissolve two substances. Now in this case, we have a polar molecule, we have a hydrogen bonded molecule. That is why they don't dissolve, and hence we have to add some acids, right? Hence we have to add some acid here. Now what is going to happen? Again, the more substituted carbon, that is this carbon atom, it is going to get the OH, and then a double bond, because the third bond is broken, one of the pi bond is broken, and here this will be CH2. Again, you can add some water. Okay, so we have the same case here, Okay. Now let us see what happens if I have, first of all, let us see what happens if I have this particular group. This is known as what? This is enol, right? This is enol. Now there will be a tautomerism. Do you guys know tautomerism? Guys, do you know tautomerism?
No, sir.
No. Okay, fine. So, यहाँ तक लिखिए, then I will tell you one thing. You just write till here. Okay. So see, we have with us this molecule that is CH3, COH, and double bond. So we have CH3, COH, double bond, CH2, C double bond, CH2. Now I hope you guys must know. Resonance, right? You guys must know resonance. So what is going to happen in this case? You have A, double bond B, and single bond C. This is a case of resonance, right? If you can see it like this. Oops, sorry. Double bond B, single bond, and then there is a lone pair. So this is one of the cases where we have a resonance. Now what will happen in resonance? OH will give a bond here, and this will go here. So what you get essentially is CH3 carbon, and there is a double bond oxygen. There's a hydrogen here. This oxygen will get a positive charge, and then you have here CH2 negative, because it is getting electrons. Now I want all of you to concentrate. I want all of you to concentrate on this hydrogen that we have. This hydrogen is already attached to a very electronegative element, that is oxygen. And now this oxygen has got a positive charge. Now this positive charge means it is a complete positive charge on the oxygen atom, which is going to pull the electrons even more effectively from the hydrogen atom. And that is why this hydrogen will be getting a very high delta positive charge, a very high delta positive charge. Now, and this is it is very close to the negative charge that we have in this carbon atom. So this carbon atom, what it will do, it will pour up the electrons to the hydrogen. And then you will be getting, and as soon as this carbon is giving the hydrogen electrons, hydrogen will be breaking the bond from oxygen, and there will be CH3, C double bond O, and there will be CH3 here. Okay. Now, if you see this reaction, this is kind of an isomerism. Here you have enol, right? That means there is an alkene and there is a alcohol, right? This is what? There's alkene here, plus here there is alcohol. So we call this form as enol form. And here, as you can see, that we have formed a ketone. Okay. So this is enol form and this is keto form. And this whole process, it is known as tautomerism. Okay, it is known as tautomerism. So what essentially happened is that this C double bond O, it is very strong bond, and that is why if we have any enol case in which the carbon which is having a hydroxy group, it is attached to a, and it also has a double bond. Okay, this carbon atom is our main carbon atom. This carbon atom has the OH bond, and this carbon atom also has the double bond. So if you have any such cases, then what will be happening? There will be an isomerism, which is essentially called as tautomerism. And by the virtue of tautomerism, this enol form will be converted to the keto form. Similar things will happen here. You have the same molecule. So this will be converted to CH3. And here you'll be getting C double bond O. And in this side, you'll be getting CH3. Now, if you add more water molecules, there will be no reaction at this particular condition where you have acid condition and some heat is present. Okay. So please, you can write this down. Let me know if you have any doubt. If I want to elaborate, if you want more elaboration on tautomerism and some more examples, please let me know. But this is the only case where you will be seeing tautomerism. Okay. The addition of water to alkyne. Addition of water to alkyne. Okay. So you guys are done. All right. Last type of reaction, that is polymerization. So we had addition, and this is what? Addition of halogen, addition reaction, polymerization reactions. Polymerization. Okay, polymerization reaction. Now in this first I will start with the cyclic polymerization, right? The first part, cyclic polymerization. Cyclic polymerization. So please look, first of all, how does this happen? In cyclic polymerization, you will take ethyne molecules, okay, and then you will pass it through a red hot iron tube at a very high temperature, So the molecule that we want is ethyne molecule and 3 moles of ethyne. So a simple reaction you first write 3 molecules of CH, triple bond, CH, and you just have to heat this, you write red hot iron tube, red hot Fe tube, at 873 Kelvin, and you will be forming benzene. Okay, so let us see how this reaction happens. You have CH, triple bond CH, and then you have CH, triple bond CH. You have CH, triple bond CH. Now, one of the bond shifts here between these two carbon atoms. Okay, one of the bond shifts here between these two carbon atoms, and one of the bond shifts here between these two carbon atoms. The same condition, we will have CH, double bond, because it has made a one bond here. Then there will be a single bond. This also has CH. This also has CH. There will be a double bond here, CH. This will have a single bond CH. This will have a double bond CH, and this will be having a single bond CH. Now you can convert and write the structure as a double bond here, you have a double bond here, and you have a double bond here. Okay, so you'll be forming benzene. You can write when ethyne is passed through a red hot iron tube at 873 Kelvin, then benzene is formed. Done, guys?
Yes.
So this is one of the example of cyclic polymerization. Okay, then you can, for example, now this is if you have 3 moles now, then if you have 3 moles, then you will be forming benzene. But if you have more number of ethyne, then you'll be forming larger cyclic molecules, Okay, so let us write about linear polymerization. Second part, linear polymerization. Linear polymerization. Now in linear polymerization, let me start with a simple example of again ethyne molecule. CH triple bond CH. Okay, CH triple bond CH. Then you will react this with you're going to react this with cuprous chloride in the presence of ammonium chloride, Cu2 Cl2, presence of NH4Cl at 343 Kelvin. Then what is going to happen? You will be making CH triple bond CH, and then there will be double bond CH2. Okay, Now, if you again react this with ethane, if you again react this with CH triple bond CH, then what will happen? You will add, now this triple bond will be intact, and then you will be adding one molecule in this carbon atom, the CH2 molecule. So you will write the C triple bond C as the same C triple bond C. This fragment will be same from here to here. Okay. And then you will be having CH double bond CH2. The same type of molecule you will be having in this carbon also. CH double bond CH2. Okay. Now, as soon as you keep adding more and more number of carbon atoms and more and more number of ethyne molecules, you will be getting larger and larger polymer. CH, this is triple bond CH. Okay. Now this condition is same here also. Cu2Cl2 and NH4Cl at 343 Kelvin. Okay, so write this down if you know you're done. There is one more reaction you can write. The special conditions. Ethane is converted to polyethane. Ethane is converted to polyethane, and the formula for polyethane is CH double bond CH, then single bond CH, then again double bond CH, which will be further connected to some other element, some other carbon chain again. And this unit, it will be repeated for n number of times. Okay, you guys are done. Right, next, aromaticity. Okay, now please listen from there. Here, this is new topic, aromaticity. Aromaticity. Okay, when and where, how will you say that a particular molecule is aromatic in nature? How a particular molecule is aromatic in nature? Okay. Now, you write here the first point, criteria for aromaticity. Okay. Right, the molecules that follow the Huckel rule Huckel rule are aromatic compounds. Okay. Now the Huckel rule, there are few points that you have to remember. Huckel rule. Okay. So first point is delocalization of electron. A complete delocalization. Complete delocalization of pi electrons. Complete delocalization of pi electrons in ring. So you also have to have a ring. Second is molecule should be planar. Molecule should be planar. The third rule is right. The third rule is molecule should contain molecule should contain 4n plus 2 pi electrons, where n should be equal to 0 or 1 or 2 or 3 or so on. Okay. Write this down. Let me know if you're done. So the last statement, it is generally known as the Huckel rule. Okay. Last statement is generally known as the Huckel rule. So Huckel gave only the third rule, and these major 1, 2, the 1, 2 rules, these were major contribution later on. Huckel gave this rule. The third rule: if a molecule it has 4n plus 2 electrons, where n is equal to 0, 1, 2, or 3, then it will be a what? Aromatic molecule. Write this down. Then we will do some examples. Okay. I hope all of you know resonance. Yes or no? Guys? Keep your hands. I have lowered your hands. You guys know resonance, na? Yes.
sir.
Okay, Parvati, Yusra, Razan, all of you?
Yes.
Okay. Just wait a. Okay, fine. So you understand what is complete delocalization of pi electron? There should be resonance. Okay. You guys understand? Complete delocalization of pi electrons? Yes.
Yes.
Okay, fine. And the molecule should be planar. It means that the molecule should be having, it should be planar in structure. That means sp2 hybridization should be there. Okay. sp3 nahi hona chahiye. It should not be sp3. Okay. sp3. It should not be tetrahedral. It should be planar. The structure should be planar. Okay. So let me write a question. Are the following molecules aromatic? Okay. Are the following molecules aromatic? So I will start with something that you already know, that is benzene. But from benzene, what we will do, we will generalize a particular steps on how to check if a particular molecule is aromatic or it is not aromatic. Okay. Right now we are just concerned whether it is aromatic, yes or no. If they will say it is aromatic, is it aromatic? We'll say yes or no. We will not classify non-aromatic or anti-aromatic at this point of time. Okay. Now, let me say if I will give you a molecule something like this. Okay. So what do you guys think? Is this aromatic or is this not aromatic?
Not aromatic.
No, not aromatic. Okay. So what is the criteria that it is not? It is a ring, fine. But what is the criteria that it is not following? What is the criteria that is not following? The criteria is that there are two criteria that it is not following. It is not following the delocalization. The delocalization of pi electron, and it is also not following what? It is also not following the planarity. The structure is not planar. Okay. Because it is what? This is sp2 hybridized. We have hydrogens here. Please remember we have hydrogens here. But let us look at a structure that is aromatic. Obviously, that is benzene. Okay, that is benzene. So first of all, is this a ring? Yeah, it is a ring. So okay, fine. This is a ring. Then we can move further, and then we can ask that is there resonance? Yeah, there is a resonance. And is the resonance completely? Is the resonance complete? That means complete delocalization of electron is taking place. Yes, there is a complete delocalization of electron taking place, because if I start from this and I make a resonating structure, then it will be, so all the pi bonds are taking part in resonance. All the pi bonds are taking part in resonance. So I can say resonance, all pi bonds are taking part. And hence I can say what? It is complete delocalization. Complete delock of pi bonds. Next is, I will check the planarity. Is this planar? Yeah. All the molecules, all the carbon atoms, sorry, all the atoms, that is carbon atoms, they are sp2 hybridized, right? If all of them are sp2 hybridized, then it is going to be planar. So yeah, it is planar. The next is, and the very important part is the 4n plus 2 pi electron. 4n plus 2 pi electron. Now, 4n plus 2 pi electron, how are you going to see whether it follows the Huckel rule or not? 4n plus 2 pi electron. So what you are going to do, first of all, you will tell me how many pi electrons are there. Tell me, guys, how many pi electrons are there in this particular structure?
6.
All of you understand this? Because this is 3 bonds, and there are 3 bonds, that means 6, right? So 4
Yes.
n plus 2, this should be equal to 6. Okay, you will write it like this, then you will calculate the value for n. So you see that n will be equal to how much? 4n. This will be equal to 6 minus 2, which is equal to 4. So 4n is equal to 4 and n is equal to 1. Now, as we have got n is equal to 1, it is following. It is saying that molecule should have 4n plus 2 pi electrons, where n should be equal to either 0 or 1 or 2 or 3 or so on. So it is fulfilling the criteria that n is equal to 1. Okay, n is equal to 1 and n is not equal to half or something else. And that is why I will say that benzene, it is aromatic molecule. Benzene, it is aromatic molecule. So there are 2 points that you have to first remember regarding this 4n plus 2 pi electron. First of all, you need to know how many pi bonds are there in a particular molecule. Okay, so first of all, write this down. Let me know if you're done. Write this down. Let me know if you're done.
So n is the value for what?
N is the value for nothing.
Hmm.
Okay. It is just that n should be equal to 0. If you equate 4n plus 2 and the number of pi electrons, then the number, then the n should be equal to 0 or 1 or 2 or something. It's okay. Like 1, 2, 3, 4, and so on. Okay. So I think I can move on. Next structure that I'm going to look is, I don't know which example is this. See. Okay. So first of all, you will tell me, is this a ring? Yes or no, guys? Is this a ring?
Yes, sir.
Yes. Sir.
Yes. Okay. Can you see resonance here?
Yes.
Yes.
Yes. Okay. What is next point? After resonance, what do we look? Is there complete delocalization? Complete delock? Right? Yes, because this can go here and this will go here. And the resonating structure, that means all the pi bonds are participating in the resonance. All the pi bonds are participating in resonance. So ring is there, resonance is there, complete delocalization is there. What is the next point? Is it planar? So for checking the planarity, you should see that none of the carbon atoms should be sp3 hybridized. Okay, it should not be sp3 hybridized. So tell me, planar or not planar?
Planar.
Planar, right? All of them are sp2 planar. What is the next criteria? After complete delocalization, 4n plus 2, na? So now you tell me number of pi electrons. How many pi electrons are there? 4. Very good. Pi electrons is equal to 4. Yes, you are correct. So what you will do now, you will equate 4n plus 2. It is equal to 4. So what you are going to get? 4n, it is equal to 4 minus 2. And 4n, it is equal to 2. So n will be equal to 2 by 4, which is equal to 1 by 2. Yes or no? Now
Yes.
I will write, since n is not equal to 0 or 1 or 2 or something else, that is why, hence it does not follow Huckel rule for aromaticity. called aromaticity. Okay. So when I say S, it should not be sp3. Na? So, but please remember that I'm talking about the shape. Don't think about the electronic geometry. I'm talking when I say sp3, then I'm saying that none of the carbon atom should have a tetrahedral structure. The geometry can be tetrahedral, but the structure should not be tetrahedral. Okay. So write this down. Let me know if you're done. Done, guys.
Yes.
Okay. So I'm writing some examples. Okay, I'm writing some examples of aromatic compounds. Some examples for aromatic. Okay. Aromatic compound. You have already seen benzene. So if you fuse two benzene together, now again here you can see that everything is just as the benzene ring. And here how much pi electrons do you have? Number of pi electrons. It is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons, right? And here if you will calculate the n, it will be equal to 2, and that is why it is aromatic. N is equal to 2. It is fulfilling the criteria for the Haeckel rule. If you add one more, this is known as naphthalene. So the naphthalene bonds that you have now, it has this type of structure. Then you can have one more benzene. You can fuse this together, and then you will be making anthracene. This is anthracene, and the number of pi electron it has is 1, 2, 3, 4, and here we have 3, 7. That means it will be 14 electrons, and the n, it will be equal to 3 here. Now you can also have structure like this. Okay. Now in this you will have these pi bonds. There will be lone pairs here. There will be lone pair here. That means there will be a negative charge in this carbon. There will be negative charge in this carbon. If you see here, you will feel like it is not. I mean, there is no resonance, but yeah, there is resonance, and all of the pi bonds can take part in resonance. Okay, complete cyclization, delocalization, because you can see A double bond B single bond C. So there will be a resonance like this. There can be a resonance like this. There can be a resonance like this. Okay, and furthermore, you can do it also like this. Wait a second. Rather, it will be like this. This will be going here, this will be going here, and this will be going here. Okay, so now you can see that all of the carbon atoms, it can take part in resonance. It can take part in resonance. Okay, what is this? They will have how many pi electrons? So you have 3 bonds and 2 lone pairs. That means 10 pi electrons, and this is planar. Okay, this is planar, and the number of electrons, and it will be equal to 2. Similarly, you can have, and here you will have a positive charge. Now here also we have a ring structure, and all of the atoms here are planar, and you can also see that this 2 pi electrons, all of the carbon atoms, they can be involved in the you can get this pi bond here, and this will get a positive charge. You can get this pi bond here, and this carbon will get a positive charge. Now you can see that there is complete delocalization. Now here the number of pi electrons, it is equal to how much? It is equal to 2 electrons. If you equate this to, if you equate 4n plus 2, it is equal to 2, you will get n is equal to 0, and it is also fulfilling the criteria of Haeckel rule. It is also fulfilling the criteria for Haeckel rule. Similarly, you can also have a cyclopentane type of structure, but here you have negative charge. Here you have a negative charge. Now again, you can see that there can be complete delocalization, right? And this pi electron, these 2 electrons, which can take part in resonance. Now here the pi, it will be equal to, there are 2 bonds, that means 4 electrons and 1 lone pair. That means again 6 electrons. Now 6 electrons means n will be equal to how much? N will be equal to 1. 4n, yeah, plus 2, 6 electrons, 1. Write this down, let me know if you're done. Done, guys? So let me know if you're not done. Next, I will write some examples for structures which are not aromatic. They will look like aromatic, but they are not aromatic. Okay. So the first example is if you have a simple cyclopentadiene. Now, in this, the problem is in a simple cyclopentadiene, the problem is with this carbon atom at the top. This carbon is sp3 hybridized, and that is why it is what? Not planar. This one is not planar, and it is not planar. Then the next point is that there is no complete delocalization. Complete delocalization is absent. Okay. Furthermore, you can have a cyclopentadiene cation where you have a positive charge. Now this carbon is sp2, but the problem here is that the number of pi electrons, it is equal to 4. If I will going to equate 4n plus 2, it is equal to 4. This will give me n. It will be equal to how much? Minus 2. It will be equal to half, right? And that is why it is not going to satisfy the Huckel's rule. It is not going to satisfy the Huckel rule. That is why this is not aromatic. Similarly, if you have cyclooctatetraene, so you have 4 pi bonds here. Now, as you can see, the pi, it is equal to how much? 8, and that is why the n, if I will calculate 4n plus 2, it is going to equal to 8. So 4n, it is equal to 6, and it is equal to 6 by 4, and this is not equal to 1, 2, or 3 or something else. That is why this is also not going to be. This is also not going to be an aromatic molecule. Okay, so if you want to write more examples, then you can write cyclopropene anion. Here also the pi, it is equal to 4. So for aromatic, I can say if all the criteria are fulfilled, then for aromatic, the pi electron, it should be equal to either the pi electron, it should either be how much? It should either be 2 or 6, or it should be 10 or 14 or 18 or 22, and so on. And then only if all the criteria are met, that means it should be a ring, there should be resonance, complete localization of electrons, and it should be planar. And after that, when you have to check the number of pi electrons, then you just check if there is 2 electrons, 6 electrons, 10 electrons, 14 or 18 or 22, then it is going to be an aromatic molecule. If it is something other than 2, 6, 10, 14, 18, and 22, then it will not be an aromatic molecule. Write this down. Let me know if you're done. Okay. Okay, Abdul Rahman. Let me know if you're done, Abdul Rahman. Done. Okay. Acha. Now let us go on and write about the nomenclature of benzene. Okay, nomenclature of benzene derivative, benzene and benzene derivatives. Because I think we did not do much questions on benzene when we did nomenclature. Let me see. Okay, we did, but not much, right? But you remember how we have to name the puff will be benzene, and then we'll be having. Okay, fine. So right, the correct date, yeah. Nomenclature of benzene derivatives. Okay, nomenclature of benzene derivatives. So first of all, you remember that part that the PUF will have one substituent. Okay, and then there you will be having the parent and saturation and functional group. All of these will be in the benzene. Okay, and then you will just have to identify the substituent. Then you just have to identify the substituent. Okay, so I am going to make a few molecules here. I'm going to make a few molecules here of benzene. And then you are going to just identify the substituent. Okay, identify the substituent. Number A. CS3. 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 Let me know if I have to scroll down or somewhere. Okay. I'll just reduce the size here. You have to identify the substituent in all of them. Okay. You just keep the name of substituent. You just write the name of substituent in your notebook. I will be asking just that, nothing else. Okay. Chat. Minashi, can you tell me which question? You're done till where? Yes, Minashi.
Second one.
Second one. Right.
Thanks.
You have not written after second one, Minashi?
No, third and fourth I wrote.
Sorry.
No, rest I wrote.
Achha, rest you have written. Okay, fine. Everyone is done? Yeah. So you guys need to tell me. Yeah. What is the substituent in the first question? What is the substituent in the first question?
Methyl.
Methyl.
Methyl. And it is methyl. Yes, Kali, methyl. So this will be just methyl benzene. What about the second? What is the substituent here?
Dimethyl.
Yeah, dimethyl. In dimethyl, we need to also write the numbering, because you can see that this is also dimethyl, this is also dimethyl, right? So it will be 1, 2, 1, 2 dimethyl benzene. What about the third one? It will be 1, 2, and 3.
3.
1, 3 dimethyl benzene. Okay, what about this? It will be 1, 4, right? 1, 4, because 1, 2, 3, and fourth carbon atom, 1, 4 dimethyl benzene. Okay, what about the fifth one? What is the substituent in the fifth one? What is the substituent, guys?
Hydroxy.
Hydroxy. Okay, so please remember, the name that we are going to use is from the substituent. You will not look at the functional group, because these are not the functional group. Okay, what are these? These are all substituents. So OH is hydroxy. You will just write hydroxy, because you don't need to number it now. Hydroxy benzene. What about the sixth one? What about the sixth one, guys?
Carboxy.
Yeah, carboxy benzene. You will also sometimes you can also sometimes see benzene carboxylic acid. Okay, you can also see benzene carboxylic acid. Okay, but as of now we are writing carboxy benzene. It is also fine. You have to change this later on. Okay, fine. What about the next one? We have benzaldehyde, right? So benzaldehyde, what is the year for CHO? For CHO, oxy, na? Oxy or formyl? Yes. This will be formyl benzene. Okay, formyl benzene. Now this is going to be a bit different, because here we have 2 carbons, here we have benzene group, here we have benzene group. Okay, so how are we going to name this? How are we going to particularly name this substituent here? Guys, how are we going to name this? So what you will do, you will take this as the main chain and you will name this benzene. When it is attached as a substituent, you will name this as 1-phenyl ethanol. 1-phenyl ethanol. Now here you don't have to do this because this is what? This is methoxy benzene, right? This is methoxy group. Methoxy benzene. Now this is what? Amino benzene. Okay, and this is what? Nitrobenzene. Nitrobenzene. So write this down. Let me know if you're done. Okay, Isra, fine. Okay. The next thing that you have to remember, this is the IUPAC nomenclature. Okay, this is the IUPAC nomenclature. But in chemistry, we generally use the base name. Okay, we use the base name for the benzene that we have. Hence, you write base name nomenclature. Okay, now what we need to learn is the base name nomenclature. Okay. What we need to do here is, wait a second, just can you wait a second? Oh, yeah, fine. In base name, what do we have to do? In base name, we have to identify some of these benzene derivatives. Now, they are very common in organic chemistry, and that is why they have been given their separate names. They have been given their separate names. For example, this entity here, where we have CH3 attached to the benzene ring, that is methyl benzene. It is the base. If it is acting as a base, its common name is, you have to write here the common name. Okay, and these are used even more than the IUPAC nomenclature. This is more important. Okay, the common name for these benzenes, what I am writing now. This is known as, this first one, it is known as toluene. Okay, it is known as toluene. Okay, it is known as toluene. I will talk about the second, third, and fourth later. This is known as toluene. You will just leave a blank there. Then for the fifth one, you will write this is phenol. The common name for this, if you have OH attached, then it is phenol. It is going to be phenol. Then if you have COOH attached, then the base for this is benzoic acid. Benzoic acid. Okay. Now, whenever you have a particular benzene in which the COOH group is attached, then the base will be benzoic acid. The base will be benzoic acid. Right. Next, for formyl benzene, that means if you have aldehyde, then it will be benzaldehyde. benzaldehyde. Then you have, if you have COCH3, if this ethanol group is attached to the benzene ring, then it is known as acetophenol. Acetophenol. If OCH3 is attached, it is known as anisole. It is known as anisole. If you have any NH2 attached, it is known as aniline. It is known as aniline. Now, there is no particular name for nitrobenzene, okay? Nitrobenzene is nitrobenzene only. So you write those down. The first one is toluene. After that, you just leave blank, and then from phenol, you can start writing. Phenol, benzoic acid, benzaldehyde, acetophenol, anisole, and aniline. Done, guys? Let me know if you're done. So these toluene, phenol, benzoic acid, benzaldehyde, acetophenol, anisole, and aniline, these are the what we call as base names, okay? That we use as a base to name the derivatives of these molecules. Write this down, then I will give you some question to identify the base. Done, guys? Yusra, Parvati, Yusra to break. Parvati, Khalil, Abdurrahman, guys are done?
Yes, sir.
Okay.
Yes, sir.
Okay, so right question. Identify the base in following, okay? So I am doing one for you. Let's say we have chlorine here and we have CH3 here. Okay, we have CH3 here. Now, now can anyone try and tell me what is the base that you can see? Is it any one of those that we have just mentioned, the common names in the common names? Can you see? Can you see a fragment? Can you see a fragment? For example, if you will see here, then if I remove this chlorine, then what is this? If I remove this chlorine, it is going to be methyl benzene, yes or no?
Yes.
And that is why I will say the base here, it will be toluene. Now, all of you can identify. If I give you some more questions, tell me. Hi, guys.
Yes.
Okay. What about others? Abdurrahman, Khalil, Maimuna, Razan,
Yes, sir.
Minashi? Yeah. Okay, fine.
Yes.
Tell me for this one, all of you. What is the base here? What is the base here?
Phenol.
Phenol. Very good. All of you agree? Phenol,
Yes.
Yes, sir.
right? It is phenol. Yeah. What is the base here?
Aniline.
Aniline, right? So if I remove this NO2, then this will be aniline. This will be aniline. Yeah. What will be the base here? What is the base here?
Anisole.
Anisole. Okay, anisole. Anisole and aniline. The others are okay, anisole. Yeah, one more that is difficult that people usually forget. Yeah, what is the base here?
Acetophenol.
Yeah, good. Acetophenol. Can all of you recognize this? Yes or no?
Yes, sir.
Yes, all of you can recognize this. Okay, fine. This is acetophenol. That means if you remove Br, then you're going to get COCS3. COCS3. Okay. Now, so you can now identify what is the base here. Now, how are we going to name this? See, it's very easy. You have toluene here, so you'll be keeping toluene as what? The base. Okay, you are going to keep toluene as the base. Okay, toluene as the base. Next, what do we have? We have the chlorine, right? We have the chlorine. So what you will write? So this base now, the carbon atom which is containing the group of the base, it will be numbered as 1, and then you will start the numbering here. So this will be 1, 2. Right? Here also it will be 1, OH will be 1, the carbon which is containing OH will be 1, the Br will be 2. Similarly, in nitro, in NH2, this will be 1, 2, and the nitro will be in the third position. Here in anisole, OCH3, it will be 1, and the fluorine it will be 2. Anisole. In acetophenone also, this carbon atom will be 1, and this will be 2. Now, this is the base, and you just need to tell that there is chlorine present in the second carbon. So you write 2-chloro toluene. In this case, you will write 3-nitro aniline. Okay. So can you complete the nomenclature for the rest of these three, B, D, and E? The group of base gets the carbon containing group of base, the carbon containing group of base gets the number or position. Yes, Parvati, that will be 2-bromophenol, 2-fluoroanisole. Anisole, it has E also, okay? Anisole, it has E. Anisole. SOLE. And then we have 2-bromoacetophenol. 2-bromoacetophenol. Okay, fine. So please write this will be 2-bromophenol. This is 2-fluoro. And there is no space, okay, anisole. And this will be 2-bromo. Acetophenol. Done, guys? Write this down. Let me know if you're done. Right, next. Now we use some special nomenclature if we have di substituted. If we have di substituted nomenclature, or di substituted benzenes. Okay, di substituted benzenes. Now, if I say that I have a benzene ring like this, I have a benzene ring like this, okay, and we have a substituent group that is attached in this carbon atom. Okay, in this carbon atom. Okay, this is here we have the substituent. We can have CSC or anything. That this carbon, it should be getting the number 1. Okay, it should be getting the number 1. This carbon should be getting number 1. Now I can say that these two positions, there are only a limited positions that you can have. These two positions are same. Similarly, these two positions are same, right? And we will have, let us say, this position here. So there are only 3 positions that are possible if I will have dissection. Either the carbon, it can be present in this orange one or the green one, or here this sandy color one. Okay, so it can be present in any one of them. Yes, Mazia, okay, fine, that's fine. Happy journey, safe journey. Thank you. Okay, so this carbon atom, it should be getting the number 1. Okay, this should be getting the number 1. Now I'm writing some cases. If you have, if IUPAC nomenclature has 1, 2, and a disubstituted में क्या होगा? You will have either 1, 2, or you can have 1, 3. This is second position. This is third position. And this is fourth position. Or you can have 1, 4. These are the only cases that you can have. This is also 2. This is also 3. Right? These are the only cases that you can have. Is everyone fine with this particular idea? That in a benzene, then you can have, if you have di substituted, then you can have only 3 cases. Either it will be 1, 2, 1, 3, or 1, 4. Let me give you an example. If I will have an OH molecule here, and I want to attach a Br molecule, so there can be a Br in this particular place. So this will be 1, 2. But even if I have OH here and Br here, this will be also 1, 2, right? This will be also 1, 2. If I will have OH here and Br here, this will be 1, 3. If I have OH here and Br here, it will be 1, 4. Right? Similarly, if I will have OH here and Br here, this will be 1, 3 again. So as you can see, there are only 3 places if you have a disubstituted benzene. It can be either 1, 2, or 1, 3, or 1, 4. Now, if I will have a 1, 2, then it is named as ortho. And it has a it has abbreviation O. 1, 3, then it is meta. And 1, 4, then it is known as para. Meta has a short name, that is M, and para has P. Okay. Right till here. Let me know if you're done. Then we will use a particular question. Okay, use some questions to write the name. Done, guys? Write this down. Let me know if you're done. Or also you can write one more thing. Okay. Or also you can also write The carbons which have the groups now, they are next to each other. There's a difference of 0 carbon. 0 carbon in between. In meta, it means we have 1 carbon in between the groups. And in the para, you will have 2 carbon in between. Okay, you will have 2 carbon in between. Write this down. Let me know if you're done. Raise your hand if you're done, guys. What happened? Khalil, Maimuna, Minashi, Mazia. Mazia is gone. Okay. And you're done. Okay. So let us say we have this molecule. OH and Br. Okay, OH and Br. Now, as you know, the base will be, the base name here, it will be phenol. And we have the substituent, that is bromo. Right? Now, if I want to write, I can write 1, 2. Not 1, 2, or rather I will just write 2 bromo. 2 bromo phenol. Right? But since we have 1, 2 now, that the substituent are present in the, they are adjacent carbon atoms, and 1, 2, and hence we can say that this is the case of what? This is the case of ortho. So rather than writing 2 bromophenol, what I can write? I can write O bromo phenol. O bromophenol. That means that the bromo group and the OH group of phenol, they are present adjacent to each other. They are present adjacent to each other. Similarly, if I will have something like OH, and let us say NO2. Okay, in this case, what do we have? We have nitro. So you just write nitro phenol, that is the base name, the substituent and the base name. Then you look how many carbon atoms. So this is 1, 2, 3, and 4. That means the substituents, they have 2 carbon atoms in between them, and that will be the para position, right? So this is p nitrophenol. This is p nitrophenol. You can do the same thing if you have, let us say, two chlorines like this, right? 2 chlorines like this. Now you see that this is what, you just write the name first. It is one dichlorobenzene. Next, you just see how many carbon atoms are there in between these 2 groups, between this chlorine and this chlorine. You can see that there is only 1. That means it is the case of what? Meta, and meta has a shorthand for M, right? Meta has a shorthand for M. So this is what? M dichlorobenzene. This is M dichlorobenzene. So you don't have to write anything else. You just first of all write, for example, let me tell you one more example. If you have something like OH and you have CH3, okay. Now in this case, you can either write toluene or phenol, but generally we write phenol because phenol is more reactive and phenol has a higher priority. Okay, OH, it will have higher priority because it is also a kind of a functional group. So what we have methyl phenol. And we don't have any carbon atom between these 2 groups. That is why this is ortho. That is why O. O methyl phenol. O methyl phenol. You can write for more example. For example, you have, let us say, COOH, and here you have OH. Okay. Now, first of all, let us write what is the position. The position will be what? Can anyone tell me? Can anyone tell me? It will be ortho, meta, or para? It will be ortho, meta, or it will be para?
Para.
Para, right? Because two carbons. So para. Now, I will write hydroxy benzoic acid. Okay, guys. So write this down. Let me know if you're done. Write this down. Let me know if you're done. Okay, you guys are done. So I was talking about the two things that I did not name now. So if you have two CH3 groups attached to a benzene, so it is known as xylene. CH3 and CH3. This is known as xylene. Okay, this is known as what? Xylene. But please remember that you also have to give the position. So this is what? O-xylene, orthoxylene. If I have CH3 in 1 and 3 position, this will be M-xylene. If I have CH3 in 1 and 4 position, this will be paraxylene or p-xylene. Okay, it will be p-xylene. Okay, you guys are done? So write some question for homework, okay? Following using base name and OMP. OMP means ortho meta para. Okay, wherever applicable. Wherever applicable. Okay, so just 5 examples. Okay, so this is the same thing that will be uploaded in your assignment. Okay, it will be the same thing that will be uploaded in your assignments. Just write it now so that you get more time. Next, I have to give you some questions on. I have to give you some questions on aromaticity. Right? Question: which of the following is aromatic? Okay. Explain also. You have to explain why the others are not aromatic. Explain. Okay. Yeah. Write these 4 questions. Okay. Let me know if you're done. By the way, did anyone get notice about the examinations from your schools? Yes, anyone?
Yes, sir.
Yeah.
It starts on February 10th, but I don't know the chemistry date.
Sorry, 10th of February.
The exam starts, but I don't know when chemistry is.
10th of Feb. Okay. Anyone else? Razan, Yusra, ma'am. Okay.
No, sir.
No one?
Not yet.
Not yet. Acha, like, do you have any idea also? Like it will be starting in the end of Feb, starting of Feb, or mid of Feb, starting of March?
March first week.
First week. Minashi, first week of March?
Yes, sir.
First week of March. Okay, fine. Thank you. Thank you. Thank you. No, actually, we need to check now with you guys. And with that only, we can start our class 12th. Okay. That only we can start our class 12. So please, one request would be, please join as soon as possible. Okay, as soon as possible. Don't wait for the school to start to think and to worry about the other things. Okay, please join as soon as you can, so that we will complete the syllabus, like I hope around November or something.